Sorry. All right. Question 1 says the heating element of an electric tea kettle has a resistance of 24 ohms. And is connected across a circuit of 120 volts. I'm just going to put I in here because at some point we're likely going to need our I. So we get our I by taking V over R, right? So that is, if I'm calculating it, that would give me 5 amps. All right, that wasn't necessary just yet, but I want to put it in there anyways. Okay, so this is the amount of output that our heating element is going to produce. So this is the information that we want to see as to how efficient is it based on the amount of water and the amount of time it takes to heat the water. Okay, so that's essentially where we're going. So it says, how long will it take? So how long will it take, T, to heat 500 grams of water from 10 degrees Celsius to 100 degrees Celsius. That's a change of temperature of 90 degrees Celsius, assuming no loss to heat in its surroundings. Okay, so then the other thing that we need to know is the specific heat constant. It takes 1 calorie of energy to heat 1 gram of water 1 degree Celsius. 26, I think, somewhere around there in the back of the book. Okay, so this right here is the amount of heat required to raise that temperature 90 degrees. This right here is the output within the, oh, sorry, I gotta do this a little bit different. That goes there, and this comes down to here. Okay? So I've got a Q up here, which is I squared RT over J. And I got a Q down here, which is MC delta T. Now that output is going to be the exact amount that's necessary in order to input that heat to get that temperature to rise. So we can combine these two equations together because the heat energy is going to be the same in each case. So I've got I squared RT over J equals MC delta T. And I'm actually looking for my time here. So my time would be MC delta T times J over I squared R. Okay, so I mixed in and mingled with my variables here. You can do it with the variables, or you can decide to put numbers in and then simplify it that way. That's up to you. So I've got an M of 500. I've got a C of 1. I got a T of 90. I've got a J constant of 4.19. And all of that is over 5 squared times 24. So now you got to remember that that bottom part, this 5 squared times 24, you have to have it in brackets. I had 314.25 seconds.
Yeah, that's what I got too.
Okay, perfect. So this up here is your output. And you're putting it into here to get your temperature to raise. So you've got an element that's putting an output of this amount of voltage, current, resistance, and then down here, that's the amount of heat required. Okay. All right, let's look at question 2. Electric hot plate with a resistance of 28 ohms connected across 120 volts. Again, let's find our I, excuse me, our I. That, I'm looking for my time again. So those all go together. And then this time I am, how many minutes are required to heat 750 grams of water at 4.5 to boiling point. So my mass now is 750 grams. Specifically, this time the change in temperature is 95.5. Assuming no loss of heat. Okay. So again, what I did on the last, MC delta T times J over I squared R. So I'm doing this question exactly the same as the first question. Question asked for it in minutes, so I divide by 60. 9.726 minutes. Okay. No questions or comments?
And then when you turn your mic off, I keep on like switching over to you.
Okay. All right. Okay, so page 457, there's 18 questions on 457. I think that's where you want to make sure that you're on. I'd like to see us get through those 18 questions by the end of tomorrow. They're not overly difficult questions. They actually are questions that go fast. What we just saw these are the questions that would take you the longest, and they don't take very much time. But I am going to have an assignment for you in physics this week. This will be your first one. I'll give you 3 or 4 questions at the end of the week here on it. So this will be covered page 457 and 458 as well. You have a couple of 3 worksheets in the back here. 4 worksheets that we can go through. So we're going to spend the rest of this week working through those questions and the worksheets that go with them. Okay?
Will the assignment just be on calculations then? Just like overview?
Yeah. Yeah, it'll be about 4 or 5 questions only. And then I'll get another 4 or 5 next week on the same material. Okay? Any questions about physics today? It's kind of time to start get fired up and working on it. We've got to make sure that we get lots done this week. This is a big week.
So what was that one constant again? It was
4.19. That one.
4.19.
That's Joule's that's Joule's constant.
Joules. So that's J then.
Yeah. 4.19 joules per calorie.
I don't have a copy of that formula sheet.
No. You should.
Probably send you a picture of it, Dalen.
Yeah, and I'll just print it off because I don't have one.
Okay. I'll just send it to the group chat.
Okay.
Thank you.
Any other questions today on any of this? Okay, we will, I'll be on live about, I think at the same time, but check in Moto tomorrow. I won't be in the classroom tomorrow or probably Wednesday, but I will be able to access the internet and do videos. So I don't know if I'll be live on YouTube, but I'll do a Microsoft meeting with you guys the next 2 days. Okay? All right. We'll talk to everybody tomorrow. Have a good day.
Bye.
Bye.